about what are soaps. So what are soaps? How soaps are obtained? First, before we talk what are soaps, let us see how soaps are obtained. As discussed earlier, they are obtained by water, by the hydrolysis of esters, isn't it? So what is done on a commercial scale, the vegetable oils or fats, which are also natural esters, are strongly heated in presence of water, in presence of sodium hydroxide, to obtain soap along with glycerol, that is nothing but alcohol. So any animal or plant based fat. Now what are these animal or plant based fats or oils? These are natural esters. So when they are strongly heated in presence of water and alkali like sodium hydroxide, or even it can be potassium hydroxide, they result in the formation of soaps along with water, along with the glycerol. Okay children. So glycerol is a byproduct and our most important ingredient is water, soaps. Okay. So now if by just seeing the chemical reaction, we can now chemically define what is a soap. Now what are soaps? Soaps are nothing but long chain carboxylic, long chain sodium salts of carboxylic acids. Okay. Long chain sodium salts of carboxylic acids. Okay children. So one example of soap let me give you, that is C17H35COONA. This is commonly called as sodium stearate. What is this commonly called as? Sodium stearate. So we are deriving mostly children, in order to prepare soaps, we are using the plant based oil, maybe castor oil or palm oil. Okay. So these are used in order to prepare the soaps. So this is one common example of the soap which have been obtained. So long chain, if you see how many carbons are here, 17 carbons. So C17H35COONA will result in is nothing but a soap called by chemically called as sodium stearate. Now let us see the structure. Now how does the structure of a sodium of a soap appears? Now any soap molecule will always have two parts. It will have two parts. Now what are those two parts? One, if I just you observe this structure, this formula children, it has two components. One, a negative ion, a anion and a cation. Okay, so two ionic parts. So one a positive ion part and another negative ion part. So now this negative ion part is nothing but the carboxylic chain. What is this? Carboxylic chain ion. Fine. And what is this? This is the sodium ion. So every soap molecule will have a carboxylic chain and a sodium ion. Fine. So this is the structure of your soap. So children, so let us see now how does a soap actually work upon the dirty clothes. Now as I told you, every soap molecule will have two ionic parts. One, the positive ionic part, the sodium ion, and the other is your carboxylic chain part. Okay. Now this sodium ion part is called as hydrophilic. It is the hydrophilic part, whereas this carboxylic chain, the non-ionic part, is called as hydrophobic. Now I hope by the terms itself you must have understood what does it mean. Now hydrophilic means they have a liking towards water. Hydrophobic means they do not have liking towards water and they prefer to move away from water. So this opposite nature of these two parts of the soap is actually helping in cleaning the dirt from the cloth. Okay, now what happens? So what happens is that when soap is applied on the cloth, the hydrophobic part, that is the carboxylic chain, which is organic by nature, is going to preferably cling onto the dirt. Now the dirt is also going to be oily or greasy, which is also an organic compound. Will cling to the dirt particle, whereas the sodium ion will cling onto the water molecule. So now what happens? Let us assume that there is this dirt particle. So when dirt particle, when we are rubbing soap on the cloth and when you just agitate it, when you scrub it, what happens is that the tail part, now this tail part of, we can refer this hydrophobic part as a tail part and hydrophilic part as a head part. So the tail end, which is what by nature, as I told you, it is hydrophobic by nature, is going to cling to dirt particle. Okay. Now like that, many soap molecules, the tail part is going to cling to the dirt molecule. Okay. So like this, many soap molecules will be clinging on. And how they cling? With the tail towards the dirt. Now what is this? It is dirt. So with the tail being towards the dirt particle and the head being dissolved in the water. So when you are agitating, the dirt which is present on the sticking onto the cloth will just get dissolved, not we can say dissolved, it just gets suspended in the water. So thereby the dirt is removed from the cloth. That's why the soap water will be very dirty. After you just soak the clothes for some time, the water becomes very dirty because the dirt from the cloth has been removed and just is going to be present in the water as an undissolved substance. Okay, and thereby now when they are clinging, they just form these aggregates. Now these aggregates are called as what? Micelle. So this micelle formation actually is helping in removal of water, the dirt from the cloth. Okay children, so that is how the soaps work on the dirty clothes.